In software engineering, there is a constant, brutal tug-of-war between development speed and product quality. Push your team to code too fast, and your project risks spinning out of control and crashing into a barrier of bugs and broken features. For decades, the industry tried to prevent these crashes using the waterfall methodology. Teams would spend months drafting exhaustive specification documents, attempting to predict every possible edge case before a single line of code was ever written. Agile emerged as a direct rebellion against that slow-moving bureaucracy. It promised rapid delivery, shorter cycles, and the flexibility to adapt to the market instead of sticking to a rigid plan. But as Agile spread, a massive misconception took hold. Many teams assumed that becoming Agile required burning the specification sheet entirely. They began to believe that gathering requirements was a waste of time, and that progress meant coding blindly and figuring it out along the way. The consequences of this chaos are predictable. Sprints routinely fail to deliver working software. Technical debt skyrockets as developers build on top of flawed assumptions. The entire workflow devolves into a cycle of garbage in, garbage out. Abandoning requirements doesn't guarantee speed, it simply ensures a team builds the wrong product faster. Finding equilibrium between heavy bureaucracy and pure chaos requires a specific discipline: requirements engineering at Agile, or RE at Agile. The first major trap organizations fall into is treating a user story or a Jira ticket like a mechanical work order. A manager writes a technical directive, tosses it over the fence, and expects the developer to silently type it out. Mike Cohn's user story template solves this by forcing a specific structure. As a user, I want a feature so that I can achieve a specific goal. By including the why, developers are no longer blind coders. They are immediately connected to the actual business value the user needs. Once you know the why, the requirement functions as an invitation for a dynamic conversation between the people asking for the feature and the people building it. The 3C model starts with the card. Small borders prevent dense manuals, acting as a token for discussion. Next is conversation, where debating reveals hidden technical realities. Finally, confirmation crystallizes the dialogue into a binary checklist of acceptance criteria, proving the work is complete. RE Agile replaces solitary documentation with a collaborative social practice. The next challenge is size. When an Agile team faces a massive requirement, known as an epic, they have to divide it into chunks small enough to finish within a 2-week sprint. How they make these cuts determines whether the sprint succeeds or fails. Horizontal slicing cuts work by technical layers: database, back-end API, and user interface. But isolated layers offer zero value. You can't serve a raw patty separate from the bun. When these isolated pieces finally integrate, they violently collide, causing bugs and blown deadlines. The solution is vertical slicing. You cut a thin wedge straight down through all the technical layers. This creates an independent, testable feature that contains a small piece of the database, the API, and the interface working together. In practice, you build the most basic end-to-end workflow first. Once that thin slice is working, you can push complex business rules and performance optimizations into future sprints. Perfect back-end code is worthless if the user can't interact with it. Vertical slicing ensures that every single sprint delivers real, measurable business value. Even with well-written stories and vertical slices, teams still fall into a final trap. They start working too early. To keep up the illusion of momentum, vague ideas, missing UI designs, and unresolved external dependencies are routinely shoved into an active sprint. This is prevented by a definition of ready. While the definition of done is the exit gate that proves a feature is complete, the definition of ready is the entry gate. It physically blocks half-baked ideas from entering the sprint. A requirement satisfies this entry criteria by meeting the INVEST principles. The story must be independent, negotiable, and valuable, estimable, small, and testable. If it fails even one check, it remains in the backlog for refinement. Enforcing this checklist protects the development team's capacity. It keeps missing information and unresolved blockers from polluting the workflow mid-sprint, allowing developers to focus entirely on execution. Rejecting unready work at the sprint boundary maintains development momentum by preventing incomplete ideas from stalling the production line. Healthy agile development is not a chaotic free-for-all. To move quickly without breaking your product, you need immense engineering discipline and structural rigor. In this system, product owners and developers function as a synchronized unit, moving with aligned momentum and shared purpose. Combining continuous conversation, precise vertical slicing, and strict entry gates allows this unit to balance speed with quality. True agility is defined by the intelligence and safety of a team's value definition rather than the raw speed of their typing.